Hey guys, Mr. Derry here. We're going to just do some basic circuit in Tinkercad. So let me show you how to get started. So when you come in here to Tinkercad, the first thing you're going to need to do is get yourselves into circuits. So you're going to join this class. You're going to take on a project or start a new project, a new design, and it's going to be a circuit design. So hit create circuit, and it's going to bring you into this space. It gives it a strange name, so first thing I would do is go ahead and put your name in there for the circuit. You're going to see on the right hand side there's all kinds of components. The first thing I want you to do is pull out a 9-volt battery. All right, and then pull out an LED, and then pull out a resistor. All right, so we're going to go ahead and get this thing set up in a way that makes it easy to wire. If you click on this 9-volt battery here and you come up here, you can rotate it so it's straight up and down. You can drag it, move it around. Currently my negative is on this side, and I know that this is my anode to my LED. You may remember that LEDs need to be wired in the correct positive negative or they won't work. So I'm going to flip my battery around. I'm going to click on my battery and just flip it so that this side is positive. So I can click on the end of this and connect that. Now, I can also change the color of my wire by going up here, making it red. Positive is usually red, so I'll leave that there. I'm going to leave this resistor out of the equation for a moment. So I'm going to run a wire directly from my 9-volt battery to here. I'm going to make that a black wire because that's the negative side. And then I'm going to start simulation, which is going to essentially energize this battery. So I hit start simulation and boom, I blew the bulb. What does that tell me? That tells me that I am running too much current through this LED. And the voltage is too high. So I need to drop this down. I can drop it down with a resistor. So I'm going to stop my simulation and I'm going to take this wire and I'm going to add in this resistor. And I start my simulation and the light glows. Now, what is the resistance of this resistor? Well, there's two ways I could do that. I could just take this resistor, pull in a I can delete that for a moment. I can come in here and get a meter, hook up some wires to that meter, and set it to resistance over here. And I can start my simulation. And it tells me that it is a 1000 ohm resistor, 1 kilo ohm. All right. Now, I can actually change the value of my resistor over here, change it to ohms, and let's say I want to make it 500 ohms, half as much resistance. We should get more electricity flow. I start my simulation, it's 500 ohms. Let's see what happens if I power up that LED with a 500 ohm resistor. And it still works. If I drop the resistance too low, I'm going to end up blowing my LED. Now, in our electric vehicle, we have a resistor. It's a variable resistance resistor. It's called a potentiometer, and this is what controls our speed controller on the car. And it essentially allows more current to go to the speed controller, which in turn puts more current to the motor. Let's see what that looks like. So I'm going to pull this guy out for a moment. Oops. Actually, I'll just delete it. Pull this guy in and So you can see that my light bulb is on, but it's dim. And if I go too high, my light bulb blows up. Well, how do I know what's going on here? What's changing? I'm changing the resistance of this. We could hook up our meter, and I'm going to leave it over here. Actually, let me delete that. I'm going to make, if you click, you can kind of bend the wire around so it's easier to see where you're connecting it. I want to connect it to this side, and I want to see voltage. So I change it to voltage, and now I hit start simulation, and I can see the bulb is lit and my voltage is 7.2. If I crank this up, it's a fine line here, you could see that I've dropped to a small amount of voltage, meaning this resistor, the resistance of this resistor is lower, therefore my voltage drop is less, and the current and voltage going to my LED is higher. All right, so we can look at this a different way. I'm going to delete this guy and take this and hook it up to my, I'm going to zoom out for a second. I can take this guy and hook it up to my LED and see what the voltage drop is across the LED. And we know that our total voltage is 9 volts. So the lower my resistance, the less voltage drop here, the greater the voltage drop will be here. So I start my simulation. My bulb can't handle that much. If I drop this down, what I'm doing is increasing the resistance here, and therefore the voltage drop across here should be approximately 7.3 if this is a 9-volt battery, because the voltage drop here is less. We could actually pull another meter in here and take a look at both of these at the same time. So we can hook up this guy and take a look at the voltage drop across the two of these. All right. This is set to voltage, this is set to voltage, start simulation, and you can see that the voltage drop here is 7 volts and the voltage drop here is 1.7. So the two of those add up to 9 volts, which is the total voltage of this circuit. All right, and this allows us to take a peek. We could even throw a multimeter in the circuit and measure amperage if we like. I wanted to show you guys this because this tool is actually a tool that colleges use to do some basic circuits, and it's really a fun way to kind of get yourself dive into this. To be honest with you, I thought I covered this, but we didn't, and I just want to make sure you had access to it.